Okay, so yeah, let's get started. In case you weren't here with us in the first session, my name is Luis. I am a Spaniard lecturer at the School of Computer Science and Informatics at Cardiff University. I've been living in the UK for 3 years now. And well, I do my research is in the intersection between computer science and linguistics. So this area called natural language processing. And my teaching is mostly devoted to anything Python, but more particularly focused on data analysis, data science, machine learning, and so on. So I like this topic a lot. And a lot of the content that you're going to see is actually coming from joint material that me and a good colleague Matthias Treder prepared for our own sessions. Okay, so without further ado, let's get started. Well, it makes sense, no? So we're going to have a quick recap on the basic data types and the Python terminology that we saw in the last session. And then we're going to jump straight to the last basic data type that we didn't cover in our first session, which was dictionaries. And then we will look into more algorithmic stuff like program flow and how to control when certain bits of your code run and when they don't. But yeah, let's go one thing at a time. And first things first. So we have already seen almost all the basic data types in Python, right? So we've seen number types like integer and floats, strings, Boolean types, and the very particular non-type. And we have also learned a bit about reading and interpreting the errors, the comments in our Python code, and more importantly, we got a sneak peek on sequence types, such as lists, tuples, and sets. And we have even learned how to modify these sequences. So just as a quick warm-up, of course, no, I mean, if you want to engage, go for it. I will leave a few seconds before I run each of these cells. So remember that you can run your cell by clicking on the run button or by doing control and enter. So here we've got a equals 42. We need to say the type of this variable. Let's give a few seconds. Someone wants to try your luck out. But if not, we can get the answer ourselves. Even if it could look like this is a number type because it's wrapped around single quotes, it's indeed a string type. Okay, so this variable is a string type. What about this one? This is square brackets, two sets of square brackets, inner and outer. What would be the type of this variable? There's nothing in here, right? So what could it be? So yeah, the list is the notation for the square brackets is the notation for Python lists, and it doesn't really matter what we have inside, right? So this is an empty list, but it could be a million other things. It doesn't really matter. It will only look at the type of the object, of the outer object. What about whether the output of this is 0 or not? So we've got 6 and this percentage sign and then a 3. Will this be a 0? So we can assume this is some sort of, this has something to do with division, right? Because that's why we're asking this question. Indeed, no, the output of this operation, which we stored in the variable c, is 0, and the reason is because this modulo operator computes the remainder that's left after taking the division between the left and the right operands. Now we get into more interesting stuff. So here's a question. Do you think this code generates an output of 4? Okay, so we've got a sequence here, 1, 4, 7, and we print d of 1. So a reminder that we can access the elements by position in a sequence with the square bracket notation. Right. So here's a warning, right? So even if this is correct, we cannot perform this operation on a set. And the curly braces is the notation we use for defining sets. And sets, by definition, are not ordered. So the fact that we are seeing here 1, 4, and 7 in this order, it doesn't mean anything. In the internal representation of this variable, Python doesn't have a notion of order, so it doesn't really have a way to access the first element here. So this doesn't work. Now, do we think that the length of E, variable E, is 4? And have a look here. We've got a list where we have a non type. We've got an integer function wrapping the false type, and then we multiply by 2. And so it's a bit convoluted, and we're going to print the length of the variable E, and we're actually also going to print the contents of the E variable themselves, and see why we get the answer that we are getting. And indeed, no. So when we multiply a list by an integer number, what we have is, well, in this case, a duplication of the elements in the list, but inside the same list. Right? So one could be tempted to expect this to be a list of lists with 2 nested lists, but that's not the case. So that's not how Python behaves. And our final recap, kind of warm-up exercise, would be to wonder, no, if we think that f of 2 will return the string Swansea. So we've got the f variable with a list, square brackets list of Welsh cities, and we're accessing the second element here, so it could be Swansea. That's what the question asks, but no. And this is important. Let's remember that the index positions in Python, they start at 0. So we start if is position 0, Swansea is position 1, and Caerphilly is position 2. And this is what we get if we access the second element in this list. Okay. So this was a quick recap of the most important stuff that we saw in our first session, and now we're going to go into a very flexible data type called dictionaries, right? And so let's look at a bit in detail into this. So a list is this, right? So a sequence of elements where we can have access to each of the elements by their position. So this element is in position 0, 1, 2, and so on. But a dictionary, it doesn't work like that. A Python dictionary is a set of key value pairs where we access the key by naming the key, and we get in return the value for that key. This is the notation for the dictionary, and as you can see, it's the same notation as sets, but the difference here is that each element in the dictionary is a key value pair separated by a column. So here we have 2 key value pairs, and as many as we may have later on. And this is it, right? So this is a mapping data type that will be very useful to understand when we start doing some complicated algorithms down the line in this webinar. A few facts about dictionaries. To start with, this is a collection. So it's similar to lists in some ways, and of course they're different in other ways. We will see now in which ways they're different and in which ways there are how they have commonalities. We create dictionaries by using the curly brace notation. Keys and values can be of almost any type. So this could be strings, numbers, Python functions, you name it. Values are accessed using the key. So if I want to find this value here, I need to do it via the key corresponding to that value. And dictionaries are mutable. So this means we can modify them in place and change them. And the most important part, not because they are unordered, there is no notion of an index position, and therefore they cannot be sliced. So if you remember in our first session, we had a few examples where we said, okay, give me the element give me all the elements in a list between position 3 and position 5. but you cannot do this in unordered sequences because you cannot really have access to elements by position. So how do we use these dictionaries? We can access keys calling the keys method. So in Python, there are two things, methods and attributes for the objects. When we do, this is our Python object, a dictionary. When we use the dot notation, it says in plain words, we're saying we want this object here to do something. In this case, return the list of keys it contains. Only the keys and only the values. And if we want to access the value of a key, we use this notation. Okay. So if we want to know value 1, we would do d of key of 1. Key 1 would be wrapped in these square brackets. Okay, let's have an example. We've got a dictionary here with a bunch of countries and their corresponding president. And we have stored this key value set of pairs under the president's variable. And we're going to print a string that says who is the Spanish president and who is the president of Mars. And as you can see, this is we do not have such entity, and therefore this is an empty string. So it will also show how we can store empty values or null values. Note again, that precedence of 0, this would break unless you actually have a key which is the integer 0 in your dictionary with some value assigned, then it will work. And last but not least, and this is going to be a notation that we're going to see quite often during the webinar. When we put f in front of a string, this is a very cool functionality that the latest versions of Python have. And what this allows us is to pass variables, Python objects, inside curly braces. You see how Colab treats these guys differently, so the color changes from red to black. And this is very convenient because if you remember, there are certain operations that we cannot do, for example, between strings and numbers. We cannot concatenate them. So we can't really do we cannot do this because to concatenate to a string, we have to have a string. And note that we can use double or single quotes. But with the F notation, Python will take care of the differences in types and basically inject any variable in these slots without breaking. And we're going to use this notation quite a lot. Okay, so there you go. Spain president, colon, then we have a space here, and then we have a variable. And this variable is the value for the key Spain in the president's dictionary, and the same for Mars. And as you can see here, we have only the space and nothing else, right? So this is the last character that was printed in the second print statement. Okay, now how do we add a new key? How could we add, for example, a new country with its corresponding president? We use the same notation. So d of square brackets, a new key, and then a value. There always has to be a value. That's the fundamental nature of dictionaries. We can modify dictionary values, and we can do that simply by doing the same operation that we would do when adding an item, but assigning a new value. So if we have here a dictionary where we map the number 10 to the string 10 and the number 100 to the string 100, if we wanted to replace, for some reason, this string with 100, all in capitals, we would only do this, and the resulting dictionary would have this value replaced. Another thing we saw rather briefly, I have perhaps, but I hope it stuck, was this belonging notation. So we can, basically in plain English, we can check whether an object is contained in a collection, in a Python collection, and we do this with in, or if we want to check that something is not included there, so we want to check the opposite, we do not in or. And these are the two basic statements that we can use. If you look at this, what we find is that by default, this line will return true because by default it will only check for the keys. If we do not specify explicitly that we want to check the values or the keys and the values, writing a little bit of Python code, this line will always will only return true if we have a key which is a 10, an integer 10, and in this case it returns true. This also returns true because we don't have any key which is a 0, and we do not have key 10 in the dictionary. We have it as a value, but not as a key. However, we could check whether we have 10 as a value by writing this. So this would be the same as getting all values. So d.values will return a list of values, and then we check if this 10 is included in this list of values. So this is a two-step operation, but I hope it's clear. Okay, so now we're going to have a quick note before we jump into program flow. And this is the note. We are going to have quite a few examples where we're asking the user to enter some value. So we're prompting the user to interact with the program. We do that with the Python function input, which works as follows. We have something that Python will print to our screen. This will be the prompt. We are going to enter some information which will be stored under the username variable in this line. Enter your name, and the same operation with the age. I'm not going to go into what's the default type for this input statement. The only thing we need, and one of the reasons is because we all have this convenient F notation for our strings. But the only thing we need to know is that we're going to use this quite often, right? So it's good to be to be familiar with the input statement. It's back in the day, in previous versions of Python, we had two different inputs. One of them when we were expecting the user to enter a string, and another input statement when we were expecting the user to enter a number. Now it's everything collapsed into one single statement. If we want to play with the different types, it's up to us. We have to write some code to do that. Okay, so here we've got a small example where we're going to prompt the user, let's say someone who enters our website, to enter their name, their age, and we're simply going to print a greeting, where we have the greeting here, and we concatenate these two variables, username, which is right here, and user age, which is right here. So let's say 36, and there you go. No, so this is the basic. This is a very minimalistic example of how we can use the input statements to retrieve some information from a user and then do something with it. Okay, nice. So we can now jump into the main topic of today's session, which is program flow. So you know computer programs, right? So a program is a set of instructions, just like like a recipe for cooking a dish. So it's literally a set of instructions. The particularity with computer programs, well, there are many, no, but one of them is that there's this idea of conditional execution. So depending on what's going on in the environment the program is interacting with, or simply the program flow itself, we can write certain conditional operations such that our code runs or doesn't run depending on a number of conditions. So this would be the most basic A to B execution would be, well, we have a list of lines that will be run one after the other, and when the last line is executed, the program is over. But we can do better, no? So we can, for example, have a way to check whether something is happening. That's what we would call a Boolean statement. So, you know, with a condition with two outcomes, yes or no, true or false. Let's fix this typo. True or false, 1 or 0, and so on. and that's it. No. So here we have an example where we would be inputting a name, and our program will check if if the name is John. If it is, maybe we already know that John is enrolled in math, so we print the welcome, the dedicated message for John. But if but if it's not John and it's Jane, then we know that Jane is enrolled to physics, so we print the physics welcome message. Right. So for now, we have seen if and elif, which translates to if elif translates to if the above condition doesn't hold, then let's see if this one is holding. No, so because in some cases you may want to check whether something is happening or not, and then regardless of the outcome, there's some code. But here we've got actual conditional execution, and there's a final keyword which we use to denote the fact that none of these conditions is true, and we use the else operation for this. So let's see an example. We've got this bit of code here, and it's exactly the same, no? But instead of having it hard-coded here in our messages, we're going to retrieve the majors of our users from a dictionary. Let's say we've got a university website, right? And someone logs in. We have a very simple website, and we assume we only have one person called George. So the first line of our code prompts us to enter our name. So let's say George. Now we're going to check if that name is in majors, and because by default we're only going to check for the keys, we're going to check whether this guy is either Luis, Barbara, or George. And indeed, no, we found George here, so we print George's welcome message with his, custom major. However, if we have Susan, for example, she has not been enrolled yet because this condition was not true. Okay, so this is how conditional execution works in a very small nutshell. In addition to conditional execution, there's something else, and it's the repeated or cyclic execution of some subset of your code. I think I mentioned this, an example of this in the first session. Also, when we're trying to, when a website is trying to match a username with a password, it enters an indefinite loop until the username and the passwords match, and then we're granted access, to the website. So what are the conditions for a sequential or repeated sequence of instructions to start, take place, and end? So typically there are two conditions. So either the program has finished going over a list of elements. So we have, let's say, an array, we have a list, we have a set, a tuple, a dictionary, but all these, they can be very large, but they are finite. So we may have a program that needs to do something with each element in that collection, but once our program is done with that collection, then this iterating cycle is over, and then the program proceeds to the following lines or exits. Or another condition could be that there's a Boolean condition, and yes, no, true, false, 1, 0. As long as a condition, as long as this Boolean condition is true or false, depending of our program, we can have our code doing something in an indefinite loop. But inside that loop, we will have some kind of switch that may be the exit criteria for our program. We're going to look first into this iterating over sequences, so this number 1, and we do that with the for loop, and number 2 is the while loop, which we will see in a minute. Okay, so here we've got an example. Here there's a keyword that you haven't seen yet. I don't think we need it for now, but if we have some time and someone is curious, we can go back to this example. Basically, the idea is that this program will print the characters for the name that we enter here. We will print one character per line. The point is that with range, we're actually retrieving the range of a number. So if we say range of 10, it will go from, well, in Python terms, it will go from 0 to 9, but it will go from a starting point to an end point, and it will retrieve the range. So all the numbers between the start and the end. If we pass to this range function the length of our name, it will iterate. It will give us one position for each of the elements in that name, and then we can retrieve that element. So here what we would be doing would be, for each position in the length of a name, get me the character at that position. So if someone is called Sue, S-U-E, I would be 0, so this call here would be S, the second iteration would be U, and the third iteration would be E. This will become, I think, clearer when we look at the syntax for a for loop. Sometimes it can be difficult not to wrap our heads around it. When we do for something in iterable and then a code block, and remember this is indented because Python does not care about ending lines with a semicolons or curly braces. We do have to have our code indented. This variable that we declare in the for loop gets declared and, let's say, lives for as long as this code block is running. After this code is running, this var becomes the next element in this iterable or sequence, and so on. So here is a simplified version of this guy. This guy is accessing each element in a name by position, but actually we can access each element in a word variable by declaring the variable, let's say, on the fly. So for letter in Word, this is literally saying iterate over each of these guys and then print them. But we can call this whatever we want. This is simply the declaration of a variable that is declared here. And whatever we do with this variable inside this for loop will affect the element at that element in that position. But if we after this block of code is done, then the same block of code will affect the next element and so on. A nice property, or well, instead of nice, let's say important to know property, is that if we have a word here with this hello and we write for x in Word, remember that this is simply a variable that I am declaring now, so it's not really necessary to call it letter, although it would be more self-explanatory if someone else is reading your code. But yeah, print x, right? So this is the same. Now, what do you think if I do this? What would happen now? So if you're thinking that x, so there were, I think there are two ways of looking at this. I just said that these variables get declared inside the for loop, so you could expect x to disappear from the memory of the program and not exist anymore in the last once the for loop is done. But it's not the case, no. So once we are done with it, the value of the variable that we declare here is the last element of the sequence we have iterated over. So let's get rid of these. And we have a small break because we're going to enter, let's say, muddy waters. No, we're going to have a few exercises here with the while loop. So before that, we are going to take a 5-minute break. But just for you to know that we're going to write an algorithm. So something that's a bit more complicated than what we've seen so far. And it's an algorithm that, well, it doesn't really, okay, so this is not, so fine. Let's call it find vowels, because it's not that it's going to count vowels. What it's going to do is it's going to take as input a name, just the same way we've seen through the seminar. It's going to loop over each character, just like in the same way we've seen earlier, but this program will have one functionality. It will tell us the first vowel of that name. For example, U in the case of Luis. And if that name has no vowels, the program must point this fact out. So the program has to say, apparently your name has no vowels. Okay? Okay, so we are 40 minutes, a bit more into the seminar. It's a good time to take a small break, 5 minutes at most. And when we come back, let's say at quarter to 4 Central European time, we will resume with the Python code that implements this algorithm and everything that's left. This is also a time where we can take a couple questions if there are any. If not, time to take a glass of water or visit the loo.
That was fantastic. Thank you very much, Luis.